Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 17, 2026, exactly 1 week ago. It proposes a new framework called LoRWeB that solves complex visual analogies by dynamically mixing a learned basis of low-rank adaptation modules, achieving win rates of up to 84% against competing methods. The paper is titled, Spanning the Visual Analogy Space with a Weight Basis of LoRAs. And as we'll see later, the method shows remarkable generalization to unseen visual transformations compared to previous baselines. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the visual analogy task central to this paper. Here, the model receives a demonstration pair, labeled A and A prime, which defines a specific transformation, and must apply that same logic to a new image, B, to create the result, B prime. In the top left example, the system sees a tree photo turning into an architectural sketch, so it correctly converts the yellow car into a similar technical drawing. Meanwhile, the top right example shows it can also handle complex object insertions, like adding armor to a pet, which would be difficult to specify purely with text. Figure 2 details the architecture. To the left, the input triplet, images A, A prime, and B, feeds into a frozen encoder and a projection module to form a query vector. In the top right, the system maintains a basis of low-rank adaptation modules paired with learnable keys, which act as fundamental building blocks for transformations. The model compares the query against these keys to calculate weighting coefficients, which determine how to blend these blocks into the single mixed low-rank adaptation seen in the center. This dynamic adapter is then injected into the generation model at the bottom to synthesize the final output. So, Figure 4 presents a qualitative comparison against baselines on tasks the model hasn't seen before. On the far left, the first 3 columns show the input triplet, the reference transformation from A to A prime, and the target image B. Take the top row, for instance, where the goal is to make an object look like it is growing moss. The 4th column shows that the author's method successfully coats the nightstand in moss while preserving its structure. In contrast, looking at the baselines to the right, the single high-rank adapter distorts the background. Visual Close loses the object entirely, and Edit Transfer fails to apply the texture at all. Well, Figure 4 showed us the visual quality, and now Figure 5 backs that up with quantitative metrics. The left chart plots preservation against edit accuracy, using the Gemma 3 model, where the goal is to land in the top right corner. The blue dot for this method achieves the best overall trade-off, surpassing the high-rank LoRa, the brown triangle, in accuracy, and beating the relation adapter, the pink cross, in preservation. The right chart corroborates this using standard metrics, where the method lands in the desirable bottom right region. So, while Figure 5 established overall success, Table 1 now digs into specific design choices through an ablation study. The first row displays the default configuration, using 32 basis modules of rank 4, which hits the sweet spot with a vision language model accuracy score of 5.94. By contrast, the second row reveals that simply increasing the rank to 16 actually hurts the model, dropping accuracy significantly. Finally, looking at the bottom rows, replacing the clip encoder with SIG LIP2 barely changes the outcome, confirming the framework works with different architectural backbones. Wrapping up, the key takeaway is that treating visual transformations as a mix of learnable primitives rather than a single fixed adapter unlocks much stronger generalization. LoRWeB proves that dynamic composition is a powerful approach for complex, example-based editing. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.